Okay, so I was looking at one of the videos inside of the student help, and yeah, so it's the problem was 3x cubed minus 24 over 6x squared plus 12x minus 48 times x plus 16 over 3x squared plus 6x plus 12.
Plus 12. Okay. So I think, let's see, this one here should have factored out where you recognize there's a 3 in both of them. So it'd be x cubed minus 8. On the bottom, there's definitely a bunch of 3's here. In fact, there's a 6, a bunch of that. So I'm probably going to pull that out first. X squared plus 2 minus, or 2x minus 8. And then we're multiplying by x plus 16. And on the bottom, there's again a bunch of 3's. So maybe we'll factor out the 3's, make that x squared plus 2x plus 4. Is this looking like the video so far?
Well, we did at the bottom left, at the one on the left. I was thinking that it would have been 6x squared plus 2x minus 8, but we wrote it as x plus 4 and x minus 2.
Oh, okay. So let's take a look and see if that's something that can happen from here. So if I want, or if you wanted to continue breaking this into multiplication, because multiplication's got to be probably the easiest thing to work with within fractions, because fractions by their like kind of creation are already a division statement. So let's make it multiplication and hopefully cancel some things. How could we factor this one down more?
You can do that you can do the x plus 4 and x minus 2, right?
You absolutely could. Yeah. And so that happens from this being recognized as a quadratic. So the quadratic makes us think of these four quadrant rectangles, or makes us think of like the AC method or any of the other techniques we've had. But yeah, I would absolutely think of this in terms of, can I make this into a rectangle? I'll put my x squared there, my minus 8. I could make this one be plus 4 and minus 2 with a little bit of thought to how that might work out, because this would have to be x and x. And sure enough, this would be 4x, and this one would be net minus 2x, so that would work out just fine. We could rewrite the entire denominator as x plus 4 times x minus 2. So now we've got our 6 that we're carrying down. We've got 3. Ooh, what can we do with this one?
That one could be x minus 2, x squared minus 2x plus 4.
Exactly. This one is a little bit of a difficult one to recognize, but the only times that we've explored easy ways to factor out something that's a cube is when it's a difference of cubes. And so that's when we can use that little mnemonic device we discovered in the lecture of saying it's like that SOAP acronym, where we can recognize that what we're really going to do is have the same sign as our negative right here will be the first thing that we'll factor out. We'll factor out one of the factors from the cube of 8, which is 2. And then from the rest of that, we're kind of just rippling through what has to be as a result. So this would be same opposite would be 4x, and then always positive would be the 4 right here. And I think that that works out just fine. True? Let me double check that one, make sure I didn't mess anything up. Oh, should that be a 2x on the inside? I think there should be a 2x on the inside, right?
A negative 2x.
Not a negative. Definitely a positive, because that would follow our SOAP acronym of saying that I have same, opposite, always positive. If this feels weird, here's the way that I would check this one if I'm on the test, or what I'm going to do right now to double check myself as we're working together. If I can't remember, I'm just going to try doing this thing in reverse. I'm just going to try doing it back out. So let's see what would have happened if I did x squared plus 2x plus 4 times this x minus 2. That would be my x cubed. This would be minus 2x squared. This would be plus 2x squared. This would be minus 4x. This would be plus 4x. This would be minus 8. And sure enough, that's going to cancel these away, and I'm left with what I started. So I think we factored it correctly.
Okay, then the other side is supposed to be 8x plus 2
Oh, this is an 8x plus 16 originally?
at the top right.
Yeah.
Yeah, it's supposed to be 8 and then x plus 2.
Okay, so this is supposed to be 8x plus 16 was what we originally started with?
8x plus 16.
Okay, good. Then yeah, we could absolutely factor out an 8. We would make this x plus 2. And on the bottom, we could factor that to be what? Maybe not anything, right?
Yeah, that was it.
I mean, that one, we could try muscling through it, but maybe if we are looking around, we're keeping kind of that awareness of the problem, we'll recognize that we have this right here is going to be the same as this right here, right?
Yep.
And then x minus 2 is going to cancel away. The 3's could cancel away. Take a look at that.
Yeah.
We could simplify the 8 and the 6, but maybe I'll do that on the next line to keep things from getting too cluttered. So that would be 8x plus 2 divided by, what, 6x plus 4?
Yep.
And that would simplify out to be, what, we could probably divide the 8 by 2 and the 6 by 2. That would be 4x plus 2. And on the bottom, we would have 3x plus 2, or x plus 4. And I think that's it. We'll kind of maybe just get rid of the parentheses and call it good. 4x plus 8 over 3x plus 12, right?
Yep. And then we also had checked to make sure for our what are those, the eliminated things that's not equal to 0. The x plus 2 is not equal to 0. What do you call those again? Yeah, restricted values.
Restricted values. Yep, that's the technical. Good.
And x plus 2 is not equal to 0 because if you have that negative 2, if you add it to the other side and have x equals negative 2, then it wouldn't fit with the x plus 2.
Good. Okay, does anybody else have a question I can help with, Rachel?
When you're trying to find the restricted values for this one of them is going to be the x squared plus 2x plus 4, right?
Oh, good question. So what's the meaning behind the restricted values? What are we trying to do?
When something equals 0.
Right, well, not when something equals 0, when the denominator could be 0, because that's where you have a divide by 0 error. It causes a lot of untrue statements to be at risk of being said. In fact, one of them, I was actually doing my observed lecture in my other 109 class on Monday, and I made the mistake of dividing by 0 in front of the chair of the department. So, that was awful. But, it's the exact same idea that, yeah, we're looking for times when these things could be 0, so we could say, okay, when could x plus 4 be equal to 0, and that's going to get us a restricted value of x cannot be equal to negative 4. Then we could also say something like, okay, what's another one? We could think when x minus 2, we don't want to be equal to 0, because that's going to multiply everything to 0. That gets us x cannot be equal to 2. We were trying to look for, you said x squared plus 2x plus 4 cannot be equal to 0. How would we find out when that happens?
That's what I was gonna ask. Do you solve for x?
You would, yep.
So
do you remember how to do that?
So subtract 4 from both sides.
If you try that, you'll end up getting yourself in a little bit of a jam, right?
Yeah.
Okay, then you'll have a whole bunch of quadratic stuff. This is where it's helpful to run through things with what they're technically called, so that it helps remind us of the other tools that we have in our belt. That's why sometimes the technical language is helpful, just as a way of kind of sparking in our other ideas. If you wanted to solve a quadratic, which is what this is, how do you think we'd do it?
Would you do the quadratic formula?
And that's exactly why it sparks back in. So that's exactly what we can do here. If we ever have a situation where a quadratic is equal to 0, and that's the critical first step, then we can solve it by the quadratic formula, which is nothing more than a condensed and fancified version of the completing the squares method. But yeah, we would absolutely do that here. So we do opposite of b, which is opposite of 2, plus or minus the square root of b squared, which would be 2 squared, minus 4 times a times c, which would be 4 times 1 times 4, all over 2a, which would be 2 times 1.
Oh,
and that would be saying, okay, then x cannot be equal to this whole thing here. As it turns out, what are you going to get in the square root?
Like solving it?
Yep.
Well, you get 4 minus 4 minus 16 which is negative 12, but it's a negative and it's inside a square root. So how would that
That's
work?
exactly right. You can't. You can't do it. At least it's not going to get a real answer, right?
Mm-hmm.
A real numbered answer. So the idea here is that what you have in here is actually something that never gets to 0. So there isn't a restricted value here. That feels a little bit weird, like we kind of have proof by intimidation. Let me show you the context for it. Take a look at this statement right here. This says I'm going to square something, right?
Which one?
The x squared up here.
Oh, yes.
So this one says I'm going to square something that has to be always positive, right?
Mm-hmm.
And the 4 also has to be always positive, right?
Mm-hmm.
Now this thing here can be negative, but as it turns out, any numbers that you plug in here will not be negative enough to cancel out the 4 and cancel out the x squared. And you can try this with just a few numbers in your head, like try plugging in 1. That'd be 1, or you could think of like negative 1. That'd be negative 1 squared is 1, minus 2 plus 4 is still going to be positive. If you tried it with negative 2, it'd be 4 minus 4 plus 4 is still positive. Like as it turns out, this entire thing just doesn't ever equal 0.
Oh, okay. So then
If
you wouldn't write a restricted value for that one?
Exactly.
Oh, okay, okay.
So you get a lot of different ways of looking at this thing and saying that is actually just something that is never 0. You never have a risk of that part being a negative number or being a 0 number.
Okay. And for the 3, do you also do a restricted value or no, just because you were trying to like make it smaller?
Let's see, the 3 where?
So like you crossed out in orange in the blue equations, you crossed out the 3. So, or is that just like canceling out?
Okay, yeah, so this one here, so the only time we have restricted values, again, is when we're worried about what?
When x is 0?
Not when x is 0.
The denominator?
When the denominator is 0. When that's going to happen when x is a couple of different things. Like over here, it happens when x is negative 4. And here it happens when x is equal to 2. So we're looking for when is the denominator going to be 0? So here's my question for you. Will 3 ever be 0?
No.
No, as its own thing, 3 does not become 0 ever, so it will never cause the denominator to be 0. So we don't have to worry about everything we cancel out or everything that's on the denominator, just the things that can give us trouble.
Okay. All right. Thank you.